So now let's go ahead and instantiate a computer and give it implementations from these three classes that we've created. So I can go ahead and say computer equals new computer and pass in a new NVIDIA graphics card. Let's give it a GTX 500. Let's pass in a new CPU, a new Intel CPU. Let's say 4 cores, or yeah, 4 logical cores anyway, and call it the i7. And then instantiate a new ASUS motherboard. And it's the, forgot the series of mine, so let's just do stuff. And then let's give it a CPU socket of LGA, oh great.
Things.
Help me, Jason. 1333? Is that what it is? 1733? Oh well, I can make up whatever I want.
Yeah, because that's the key detail in this that matters most.
Of course. 1336. That's what it is.
1664. Okay. Oh no, that's Stella Artois.
So now we have our incredibly biased computer, where we have an Intel CPU, GTX 500, and a stuff. And we can do so because each one of these classes that we're instantiating is ultimately a different implementation of one of these base types. So that's how these virtual members work. If these members were not virtual, then instead we wouldn't get the same behavior. If these methods were not virtual, and we did not have the keyword override on each one of these, what we'll get is nothing. Actually, we don't really get nothing. You'll notice that each one of these methods do get invoked. The CPU gets invoked, the graphics card gets invoked, and the motherboard gets invoked, but that's not what we want. We want the specializations that we've declared inside of our Intel, NVIDIA, and ASUS classes. So that's why we add the override and the virtual keywords. If we did not have these keywords, then things won't work properly. But because now I've added the keywords back, you'll notice that the correct methods get invoked.